Hey guys, welcome back to another Grind 75 video walkthrough. Today we're going to be covering validate binary search tree. So given the root of a binary tree, determine if it is a valid binary search tree. The valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. And then both the left and right subtrees must also be binary search trees. Some examples are, say you're given this tree, you have to return false because the root node's value is 5, but its right child's value is 4. And the right child value has to be greater than the root node's value, which is 5. So you return false. A high-level approach for this would be to realize that it's easy to check if direct left is less than and direct right is greater than, but also to ensure that anything to the right is greater and anything to the left is smaller. So to do this, we have to use a recursive function with 3 parameters, node, left, and right, to check validity. So the first base case is if node is none, you just return true. Otherwise, if node.val is not between left and right, you return false. And then for the recursive case, you want to check that the left subtree and the right subtree are also valid binary search trees. So what you do is call the same process on the left node, but set right to node.val, and call the same process on the right node, but set left to node.val. And then if both of these return true, then return true, that the BST is valid as a whole. So looking at a video walkthrough of this, we can see that if we have this input, again, we have to follow the steps outlined here. So initially the left value will be negative infinity, right value will be infinity, and value will be 5. So yeah, so we go down each of these. So the node is not null, so we can continue. Yes, the value is between left and right. 5 is between negative infinity and infinity. So now what we can do is recurse on left and right. So recursing on left, we have negative infinity, and then the left is 1, and the right has to be 5 because we're recursing on left. And this is also a valid subtree, so we do the same thing. Negative infinity. Now the value will be none because there's no left node. And then right is 1. So if node is none, we return true. So yep, that's valid. And then same thing for right. So yeah, for right it would be this. So 1, none, infinity. And then for the same reason it's true. So the left subtree is valid, and now we can take a look at the right subtree of 5. So the right subtree of 5 is 4, and then the left limit would be 5, and the right limit would be infinity. The node is not none, so we go to the number 2 check. But we realize that value is not between left and right here. So we return false. And yeah, so now we have true for left tree and then false for right tree. And then this as a whole makes us return false because both of these have to be true. So pretty simple problem here. Useful pattern to know. The use of a nested recursive function is always pretty useful for these situations. And yep, that's it for the video walkthrough.